In this video, we're going to solve 3 quadratic equations using the quadratic formula. One of the equations have rational solutions and then the other 2 have imaginary solutions. I'll compare the processes of both and then I'll show you also some tips and tricks in the NSpire calculator that'll make solving a little bit easier. So we have 2 problems here I'm going to actually work on simultaneously just so you can see the similarities and differences. The first thing that we're going to do is we have to set both equations equal to 0 because you can see my format here in standard form of a quadratic equation. I have to set it equal to 0 before I start figuring out what my a, b, and c values are. So in order to get this one on the left equal to 0, I'm going to have to add 6x and subtract 1 from this side. On the right problem over here, I'm going to have to add 9 and then subtract 2x to make that equal to 0. And then whatever I do on the right side, I'm going to do on the left side. So now both of my equations are set equal to 0, and I could figure out what my a, b, and c values are. So my a value is always going to be in front of the x squared term, my b is always going to be in front of the x term, and then that c is always going to be the constant. So we have my quadratic term, the linear term, and then the constant. So I'm going to set up the quadratic formula for both sides, and I'm going to plug in the a, b, and c values. Okay, now that my a, b, and c values are plugged into the quadratic formula, I want to simplify 3 different sections at once. And this is what I do. I simplify everything up front and before the plus or minus. I simplify everything underneath the radical, and then I go with everything underneath the fraction bar. So I'm going to go ahead and do that. And what I also recommend doing is for the part that's underneath the radical, I would sometimes just throw that directly into the calculator, into the NSpire, plug it in exactly as you see it, what's underneath the radical, hit enter, and then it'll give you that final answer. Sometimes that's a little bit easier than doing it by hand. So here we are in the NSpire, and I'm just going to demo one of the problems that I was doing, the one where a equals 1, b equals -2, and c equals 9. So I'm going to add in a calculator. I'm going to start off with parentheses, and I'll explain why I do this in a minute. But it will be -2, that's my b, close parentheses, I'm going to square it, and I've got minus, don't do the negative, but we go with minus 4, and then in parentheses, my a term, which is 1, close parentheses, and then my c term, which was 9, close parentheses again, and then press enter, and there you go, you've got the radicand, which would be underneath the radical of -32. Now, I said be careful with the parentheses in front. If I did a -2 and just squared it, that would not give me the correct answer. It's just going to make it a 4, is going to do 2 squared, and then just turn that into a negative. You got to make sure you put parentheses around the front, just like this. -2 in parentheses, then you square it, so you get the correct answer of -2 squared. And then underneath the radical, the radicand that you're dealing with, you got to simplify. That would be the next step. So we have 169 here, we have a -32 here. Can we simplify those somehow? And yes, we can. So for this first one on the left, I have the square root of 169. That's actually a perfect square. So I'm going to go ahead and do that. The square root of 169 is just 13 because 13 times itself is 169. So that's going to be the squared root of that. And then I could simplify from there. However, this one right here on the right side, -32, that's a little bit more challenging. I don't know, well, 32 is, first of all, is not a perfect square. So then you got to figure out if there's a perfect square that is a factor of 32. And you could do a trick in the TI NSpire that helps you identify the perfect squares. So I'm back in the NSpire, and I'm going to click this book key to the right of the 9. I'm going to make sure 6 is selected, and then I go down to number theory, and then down to divisors. Hit enter, and then I'm going to type in the positive version of the negative, or of the number that we have. So we had a -32, I'll go with +32, press enter, and then I have all the factors of 32, and we're curious to see if there is a factor that is a perfect square. So I'm going to start all the way to my right side right here with 32, and then move to my left. 16 is my first factor, and that's actually a perfect square. You also have 4 that's a perfect square too, but you always want to go with the largest one. And then 16 times what would give us 32? You could always go backwards and do 32 divided by the 16, which is, of course, 2. So I'm going to break up my 32 into the square root of 16 times the square root of 2. So a factor of 32 that is a perfect square is 16. And then we also want to deal with that negative underneath. So I'm going to pull out a -1, and I'll get into that in a second. So I pull out the square root of -1 because I know that you cannot take the square root of a negative number. It's an imaginary number. So the square root of -1 is the same thing as I. So we're going to use I to replace that negative. So we have a 2 there because 2 times 16 is 32. There's that negative there that would make it a -32. And then we could go ahead and simplify from there. Now back to my problem on the left. This is how these two differ, okay? So I have x equals, and it's a -11 plus or minus 13. Now, you could add 13 to -11. You could also subtract it. Those are like terms, so you could do that. So I'm going to separate this into two different equations. I'm going to have x equals a -11. We'll do addition of 13 and then divide it by 12. And we could also do -11, and we could subtract that 13 and then divide it by 12. And then I'll just go ahead and continue to solve for this. So that'll be 2 over 12, which we could reduce to be 1 over 6. That's going to be a final answer. That will be x equals a -24 over 12, which will be reduced to a -2. So because I could combine my two terms up top because they're just regular integers, I go ahead and separate in two different fractions and continue to solve and get my answers. However, I can't do that with this problem right here. I have plus or minus in some terms with radicals here, right? I can't do the square root of 2, for example, and add it to 2. It's just not possible. So I'm going to keep it all together. So let's go ahead and simplify that. I've got x equals 2 plus or minus. The square root of 16 is 4. I just bring down the square root of 2, and then the square root of -1 is an I. That's all over 2. And I could reduce from there, but I'm going to keep it together as plus or minus. I'm going to keep that plus or minus there. I'm not going to separate like I did with the ones on the left here. So I'm going to do x equals, and I'm dividing both these terms by 2. I'm taking 2 and dividing it by 2. Like that, and then plus or minus, and then this term on the right side, I'm going to divide it by 2, which is 4 times the square root of 2 times I, and that's all over 2. I can simplify a little bit more. 2 over 2 is just 1, plus or minus 4 divided by 2 is 2, and then we've got the square root of 2 times I, and that would be my final answer right here. However, I still have two solutions. It's 1 plus 2 times the square root of 2 times I, and we also have 1 minus 2 times the square root of 2 times I. All right, let's go ahead and do one more problem. So here's the third problem we're going to do. We have 8x squared plus 9 equals -4x, and our first step is we need to set it equal to 0 so that we could figure out what our a, b, and c terms are. So there you have it. We have an a that will be equal to 8. We have a b that will be 4, and then we have a c that will be 9. All positive numbers here. So now I'm going to set up my quadratic formula. I'm going to plug everything in. And I'm going to simplify the three sections. I'm going to deal with this part first. And I'm going to plug everything underneath the radical in the NSpire, and I'm going to do everything on the bottom. So that's a huge number now underneath the radical. I have -272, and it might take me a minute to figure out if there are any perfect squares that are factors of 272 so that I could reduce it. So that's when I jump back into the NSpire and use a feature that would help me realize what perfect squares, if any, are factors of 272. So we go to the book key, number 6, number theory, and then down to divisors, hit enter. I plug in a positive 272, hit enter, and I look for my right side, 272, 136, not a perfect square, 68, no, 34, no, 16, or no, 17, no, but 16, that is a perfect square, and then also 4 is a perfect square too, but again, we always want to go with the larger perfect square. So I'm going to take 272 divided by 16. And I know that 16 times 17 will be 272. So that's how I'm going to break things up. So now that I know that 16 is a factor of 272, I'm going to break this, or kind of separate everything, showing the factors. And I broke it up into 16 times 17 because 16 times 17 is the 272. And then there's my -1, which will eventually become an I. So let me give myself a little bit more room here. I'll continue to simplify. X will be equal to -4 plus or minus the square root of 16 is just 4. Then I have the square root of 17, and then that becomes an I. It's all over 16. And then I'm going to simplify a little bit more. And I always like to break this up into two separate fractions. So I have -4. I'm going to divide that by the 16. Plus or minus, I have then my other term here, which is divided by 16 as well. So I have -4 over 16. That would reduce to be a -1 over 4. Plus or minus this 4 over 16 would also reduce to be 1 over 4, which would just leave me with the square root of 17 times I up top divided by 4, because there's an invisible 1 there. Let me rewrite that. There's an invisible 1 right in front of the square root of 17 that would represent the 1 over 4. So that would be my final answer right there. You could also write it as one fraction if you'd like to. You don't have to separate like that. So it could also be a -1 plus or minus square root of 17 times I, and then all over just a single 4, because you're dividing both terms by 4. So you could keep it together if you'd like to. I just like to separate it sometimes. It helps me see how you could reduce it.